Welcome the grade 12s. This is Mr. the Visitor, and we are looking at a June 2023 question paper, mathematics, and this is what we are provided with. So we are in question 3. Okay. And in question 3, we are given a Cartesian plane, x and y. We have a straight line like this that goes like this. And we are given that we have an angle of 63. The angle here is 63.43, and we are told that this is B, and let me go a little bit higher. This is C, and this is A, and they say this is equal to that. And also we should note that we have an angle here. We have an angle there, which we can say this is an alpha, and we have E, and that E, we are told that this is D, and this is parallel to that. And what else are we given? The equation of this line. The equation of that line is y equals minus x minus 11. Y equals minus x minus 11 is the equation of that line. We have f here. We have F, we have E there, we have A, and the coordinate of A is minus 1 and 1. And what else is provided? I think that's all what we have. We may want to go to the statement that is provided just to make sense of that which is given unto us. And when all that is done, we will see what has to transpire. So everything I think has been named according to the numbering system used in here. So in the statement they say in the diagram, the equation of the line AF, we can look at AF there, it is y equals minus x minus 11. That is true, we have the equation of that line because it is a straight line. B is a point on the x-axis. And we should know that they say B, a point on the x-axis, is the midpoint of the straight line joining A and C. So B is the midpoint of the straight line joining A and C. Okay, that's fine. That's very good. So this, it's true that it is the midpoint because the distance from B to C is the same as the distance from B to A. So it's true that it is a midpoint by just looking at those lines that are shown to us. This line showing us that this is equals to that. All right, Makeba. Right, the angles of inclination of AF and AC are alpha and 63.43 respectively. That is provided to us. AF cuts the x-axis in E. Do we have E? Yes, we have E, there it is. Okay. D is a point such that DE is parallel to AC. D is a point such that DE is parallel to AC. We can see with those arrows that are provided for us today. Okay. I think we have made sense of the diagram. And then what is it that they want? Now in 3.1 they say calculate, and in 3.1.1 they say the value of t. Oh, sorry, this is t. This is not 1. I'm sorry. The coordinate of A is minus 1 and t. So they want us to find the value of t. By just looking at this, I can see that the value of t is a y value of A, and I know that y is negative in this lower boundary there. So I must find a y value that is negative. I have the equation of that line, which is provided to me, that y equals minus x minus 11. Right. And I'm looking for the value of t. Please do not say that this point is x or y intercept. No, this is a point on your straight line where you have the equation of that line as minus x minus 11. So what you do, this point has x and y. You take this point, where you see x you write minus 1, where you see y you write t, and then you find the value of t. So y is t minus, what is x? It's negative 1 minus 11. And you will find that t equals 1 minus 11, which is minus 10. So the coordinate of t will be minus 1 and minus 10. That's how we find the value of t. I think that makes a lot of sense. I think that we all agree with that. We all agree with that. Right. Let's go to 3.1.2. And in 3.1.2, they say find the size of angle alpha. And when you look at that angle, it is very important that you note that this is the angle that the straight line makes with the positive x-axis. Sorry, with the axis there. Now this angle, because we are going in a counterclockwise direction, we always produce positive angles, and then when we go in a clockwise direction, we produce negative angles, just as a rule that one should always keep in mind. So meaning, because we are going in a counterclockwise direction, we must produce a positive angle there, and this becomes very easy for us to solve. Why? Because we already know the gradient of that line. We know the gradient that the line, the gradient of the line AF. So I know that the angle there will be an angle that is made by the gradient. So what I can say, or what I'm trying to say, is that I know that the tangent of theta is equals to the gradient. This formula is always provided. And what I can say is that the tangent of theta equals the gradient. Now, what is my gradient there? The gradient is negative 1. The gradient is negative 1. So I have my negative 1 there, and I'm looking for the value of theta. So I can divide by 10, divide by 10. This into this goes once, leaving you with an angle. There's a 1 there. I want to write this as a base. I know that the exponent becomes negative when you write that as a numerator, this as the base, no more as a denominator. And you will have your negative 1 there. Right. And because the gradient is negative, you know that you're going to come here and just add this to 180 degrees in order to produce a positive angle. Now let me just go to the calculator very quickly and try to see the value that we can find. So I'll say arc 10 of negative 1 plus 180, and I find a value of 135. 135 degrees as the angle there. Now the question, does that angle make any sense? Does the angle make any sense? Yes. By just looking at the space, let me show you something here. I want you to look at the axis. There it's your x-axis, meaning this becomes your 0 reference. You are measuring an angle from here, moving in a counterclockwise direction. It's highly probable that the angle, looking at the space open there, it's highly probable that the angle will be 135. This is an angle that is bigger than 90 but less than 180. So this makes a lot of sense. It's less than 180 because you will make 180 when you reach this. From here to there, it's 180. Hence, I'm saying this angle is less than 180 because look where it ends. So this angle is 135 in that sense. So you will have your tan, arc tan of -1, you add 180, if your gradient it's negative, and then you will produce a positive angle. Something that we just have to keep in your mind. So we are fine with 3.1.2. Let's go to 3.1.3. And that is Kejekej and Mulotwa himself. Right. They want the gradient of AC to the nearest whole number. Now I know that the gradient of AC will be the change in Y over the change in X. And they are talking about A and C. So you will write the coordinates of A. I already know that's -1 and -10. And you will write down the coordinates of C. We have a problem here. I do not have the coordinate of C. So how will I do this? I don't have the coordinate of C. So meaning C there, it's just X and Y. So I can't substitute into this because I will require it. Now this method, it's going to fail. Now which one do you think will work? I know, remember, I know that I have the angle that the line makes with the x-axis. I know the angle, so I can find the gradient. So the gradient of AC, remember, you will say tan theta equals the gradient. You have the angle. What is the angle that AC makes with the positive x-axis? 63.43. And this is equals to the gradient. And remember, they said to the nearest whole number. Now I go to my calculator and I say 10 of 63.43. And what value do I have? 1.999, which can be approximated as a whole number of 2. So the gradient will be 2 there. Let's not use this, let's use equal sign. The gradient will be 2. And that's how you should find the gradient of that. Whenever, you must be very, very careful there. Highly careful there. Because even though you don't have the value of C, but you know how to find the gradient, whenever an angle is provided that the line makes with the positive x-axis, you will say tan theta equals the gradient. Where you see theta, you substitute the gradient there it is. It is on the x-axis. If this angle was an angle here, we wouldn't use, in fact, we would use the same angle. We would just say these angles are vertically opposite angles. So if it was here, we know that the angle here, it's always the angles there. But when we talk about straight lines, we must always substitute an angle that is made with the positive x-axis. An angle that is made with the x-axis, it has to lie on the x-axis. It has to be an angle that is measured from the x-axis as the line, the standard 0 angle, and then moving in a counterclockwise, and then that's the angle that we must use for that. Something that is just worthy of noting. Okay, that's fine. This is fine. I cannot explain it any more than that. That was the 3.1.3, and now we go to 3.2. Now, in 3.2, they say determine the equation of AC in the form y equals mx plus k. So they want the equation of AC. Now, I know that y equals mx plus c. If ever I want the equation, I just have to take one point that lies in that line. Remember, they say the equation of AC. I can't take C, I don't have X and Y, but I can take A because I'm looking for the equation of A and C, the line AC. I have the coordinates of A, which is minus 1 and minus 10. So that's exactly what I'm going to take. My y is minus 10. My gradient is 2. Remember, they set to the nearest whole number. And my x is negative 1. And now I can find c. Negative 2 plus c. This is minus 10 plus 2, which is minus 8. Then y equals mx plus c. Write the value of the gradient, that would be 2. Leave x and write the value of c. And you are done. That becomes the equation of the line AC that makes an angle of 63.43 with the positive x-axis. When we are done with this, don't think that you have mastered analytical geometry. No, a lot is yet to be unpacked. Alright, let us try to look at 3.3.1. Now in 3.3 they say calculate, and in 3.3.1 they want the coordinates of C now. Jesus. There comes a problem now. How do I find the coordinates of C? This is highly problematic. Highly problematic. Now, I have to find those coordinates of C. I know that B is a midpoint, okay? And by just looking at the equation that I have just found, that says y equals 2x minus 8. I can see that this is an x-intercept. B, this midpoint of AC, is an x-intercept because the value of y there is 0. So for x-intercept, because I have the equation of that line, I know that for x-intercept, y is equals to 0. So 0 equals 2x minus 8. 8 equals 2x, and your x is 4. Now I have the coordinates of B as 4 and 0. Now that I have the coordinates of B, I can use the midpoint formula to find the coordinates of C. So I can say the midpoint of AC is equals to whatever that is having the midpoint there. So what I'm trying to say is the following. I can say the midpoint formula, remember the midpoint for x equals x1 plus x2 divided by 2, and the midpoint for y equals y1 plus y2 divided by 2. But what midpoint am I talking for? Remember, I'm looking at AC. So I have my A with minus 1, minus 10, and my C with x and y. I can say x1, y1, x2, y2. What is your midpoint of x? My midpoint of x is 4. Equals, what is my x1? Negative 1. My x2, positive x divided by 2. What is my midpoint of y? 0. What is my y1? Negative 10. Plus, what is my y2? Y divided by 2. Something that you should have learned in grade 10. This is a basic problem from grade 10. Finding the coordinates of C when you have the midpoint and another point there. This is grade 10. We don't have to argue with this. Right. So what I can do, I can cross multiply, or somebody might multiply both sides by 2. The choice is yours. So by doing that, this into this will go once. 2 times 4 is 8. And you have your minus 1 plus x. You can cross multiply. Times 2 goes once. 0 times 2, it's still 0. You have your minus 10 plus 1. Okay, that's fine. So you can say 9 equals x, or 10 equals 1 as the coordinates of C. Let's check if all that makes sense. Is x positive? Yes. It's y positive? Yes. And the coordinate of C must be bigger than, x value must be bigger than the value of B. The value of B for x is 4, but the value of x for c is 9. So this makes a lot of sense. It makes a lot of sense. Something that just requires that you sit down and you look at as thoroughly as you can. As thoroughly as you can. I'm not going to show many methods of looking into that, but this is just the basic standard way of finding those coordinates. Right, that's fine. They say that in 3.3.2, they say in 3.3.2 that we should find the size of FED. They want the size of FED. In triangle FED, find angle E. In triangle FED, find angle E. So where is the triangle? FED. FED. So let me just close. Right, let's continue, guys, and look at 3.3.2. They say find the size of FED. They are looking for the size of FED. So meaning, in triangle FED, find angle E. In triangle FED, find angle E. So I'm going to do this and say there is my E. And by just looking at that angle, I can see that, okay, that angle is an angle that is bigger than 90. I already know alpha. I calculated that, and that was 135. Okay, and it's just an angle there. Okay, that is fine, no problem with this. And now, what am I going to do here? Okay, the angle there, it's 45. That's a straight line angle. And I can do this. And I can find maybe the angle there is 45. So I have 45 there. I'm left only with this one. Okay. Okay, but I know that this and this and this makes a straight line. But I'm not interested in that one. I am just interested in this one. So how am I going to do this? Okay, I know vertically opposite angles. This must be 63.43. And what is that going to help me with? I also don't know. But because this line is parallel to that line, there must be some corresponding angles that I can come up with. Can you see that? There should be some corresponding angles that I can come up with. So if this line is parallel to this line, and we have let me do this. We have this, and we are told that this line is parallel to that line. I know that the angle here is equals to the angle there. This is one thing I know. The angle here, the inside angle, is equals to the opposite outside angle. And what should that angle be? This one. This one. Can you see that? So this angle must be 63.43. So this is 63.43. According to this, the inside angle is equals to the opposite outside angle. These are corresponding angles. So this corresponds with that. Okay. So if that is 63.43, where does that put me? Where? Because I need to subtract this angle here. I'm not looking for that. Okay. But one thing I should know or note, these angles are vertically opposite angles. And I know that vertically opposite angles must be equal. So if they must be equal, What does that tells me? It tells me, okay, I should say that the angle here must be equals to the angle there. And how am I going to achieve that? To say that 135 minus 63.43, and I'll get 71.57. I get 71.57 degrees. So in other words, if this is 45, the entire angle here must be running short of 71.57 in order to be equals to 135. So meaning my angle there, I can say, okay, I can say, let's say FE1D equals 45 degrees. That angle that we found there. And then we can say the reason is straight line angles. Looking at this straight line angles. That's fine. Or somebody can say corresponding, it doesn't matter. So I can say, I know that E2, I'm going to call that E2. I know that FE2D must be equals to, I'm now speaking of this. Remember, when you have this angle equals that angle. So I'm talking about this. So I'm saying that FE2D must be equals to 135 degrees. Reason is vertically opposite angles. So meaning FE2D must be equals to 135, in fact, must be equals to, yes, 135 minus 63.43. That gives me a value of 71. Where did I write that now? Jesus. 71.57 degrees. And therefore, FED must be equals to 63.43 plus, it's not going to work. It's truly not going to work. Plus 45. Yes, plus 45. There it is. Plus 45. So I'm going to say 63.43 plus 45 degrees. Because look, I now have the angle here as 71.57. I have that. So I'm going to say 71.57 plus 45. And that should give me 63.43 plus 45. And I'll get a value of 108.43 degrees as the value of size angle E. And I think that might work. I'm not very sure of the value, but I understand the geometry, and I think my geometry makes a lot of sense. There might be different ways of looking into this, but this is exactly what I have. And I think that should be correct. I think I believe, in fact, that this is the correct value there. Right. Let's continue in this and look at 3.4. They say G is a point such that EAGC in that order is a parallelogram. G is a point such that EAGC EAGC. So meaning EAGC should be something like this. So that must be